In this video, we are going to discuss successive differentiation learning outcome. At the end of this session, students will be able to apply Laminar theorem to find nth derivative of product of two functions. Now, first of all, we will see the Laminar theorem. Here, Laminar theorem is used to find the nth derivative of product of two functions. We have already seen how to find the nth derivative of some standard functions. Now we will see in this session how to make use of the Laminar theorem to find the nth derivative of product of two functions. Statement is, if y equal to u into v, where u and v are two functions of x whose nth derivatives are known, then nth derivative of y, that is y suffix n, is equal to uv suffix n is equal to u suffix n, means nth derivative of u into v, plus nc1, n minus 1 derivative of u and first derivative of v, that is v suffix 1, plus nc2 into u suffix n minus 2 and v suffix 2, here suffixes denotes the order of the derivatives, plus nc3 u suffix n minus 3 v3 and so on, and n term is plus ncn u into vn. The theorem can also be stated as, if you find the value of NCR, you get yn equal to u suffix n into v, means nth derivative of u into v as it is, plus n into n minus 1 derivative of u into first derivative of v, that is v1, plus n into n minus 1 by 2 factorial u suffix n minus 2 into v2, that is n minus 2 derivative of u and second derivative of v, plus n into n minus 1 into n minus 2 by 3 factorial into u suffix n minus 3 into v3, means n minus third derivative of u and third derivative of v and so on. The n term will be u as it is and the n derivative of v, that is v suffix n. That is, after simplifying this above step, we get this, and directly we can make use of this statement to find the n derivative of y equal to u into v. And now we will see with the example, find the nth derivative of y equal to x square into e raised to 3x. Here x square is one term and e raised to 3x is another term, two different types of functions, and what you get here, y is a product of two functions. Now here y equal to x square e raised to 3x, let us consider here u as a e raised to 3x, where you can write the n derivative of this, and v as a x square. And as we have already studied in earlier sessions, that is nth derivative of e raised to ax is a raised to n into e raised to ax, that is nth derivative of e raised to 3x is 3 raised to n into e raised to 3x. Now differencing n times using the Laminar theorem. Again here we will state the Laminar theorem. If y equal to u into v, then yn equal to nth derivative of u into v plus n into u suffix n minus 1 derivative of u into first derivative of v and so on. Now we have to substitute nth derivative of u, v, n minus 1 derivative of u and first derivative of v and so on in this statement, which you can write. First of all, you have to write the n derivative of u, that is u suffix n, that is here un is 3 raised to n e raised to 3x, and into v. What is v here? V is x square, plus n into u suffix n minus 1. In un we are replacing n by n minus 1, that is 3 raised to n into 3 raised to n minus 1 into e raised to 3x, and v1 means first derivative of v. V is what here? X square, and derivative of x square is what? 2x, plus n into n minus 1 by 2 factorial into n minus 2 derivative of u, that is in un we have to replace n by n minus 2, that is 3 raised to n minus 2 into e raised to 3x, and v2, v suffix 2 means second derivative of v, second derivative of x square, that is v is what? 2, plus next what to get? N into n minus 1 into n minus 2 by 3 factorial into u suffix n minus 3, and v3 third derivative of x square will become 0. Therefore here what? Directly here only nth derivative terminates. And now we can simplify here. Therefore, yn equal to what? We can take e raised to 3x common from each term, that is e raised to 3x into bracket 3 raised to n and x square plus this n and 2x, that is 2n and 3 raised to n minus 1 into x, and here 2 by 2 factorial will get cancelled, and n into n minus 1 into 3 raised to n minus 2, and here already you have taken e raised to 3x common. This is what the end derivative of y equal to x square e raised to 3x by using Laminar theorem. Now pause the video for a while and find the end derivative of y equal to x square sin x. I hope you have completed. Here y is equal to x square sin x. Let u equal to sin x here and v equal to x square. Always we have to take algebraic function as a v. And now nth derivative of u, we have already discussed here. Nth derivative of sin ax is what? A raised to n sin of ax plus n pi by 2. Therefore, here a is 1. N derivative of u is what? U suffix n equal to sin of x plus n pi by 2. Now, by using again stating the Leibniz theorem, yn equal to what? N derivative of u into v plus n into u suffix n minus 1 into v1 plus n into n minus 1 by 2 factorial into u suffix n minus 2 into v suffix 2 and so on, plus u into v suffix n. Now here substituting the terms, yn equal to un is what here? Sin of x plus n pi by 2 and v is x square plus n as it is, and here in this un we have to replace n by n minus 1, that is sin of x plus n minus 1 pi by 2 into first derivative of v is what here? 2x, that is derivative of x square is 2x plus n into n minus 1 by 2 factorial into n minus 2 derivative, that is sin of x plus n minus 2 pi by 2, and second derivative of v is what? 2, and next third derivative of v will become 0, therefore directly what you have written here? 0. And now we can simplify and we can write which is equal to, again here we have repeated the same term for reference, which is equal to, first of all here we have written x square sin of x plus n pi by 2 plus 2x into n, we can write 2nx sin of x plus n minus 1 pi by 2 plus here 2 factorial and 2 will get cancelled plus n into n minus 1 sin of x plus n minus 2 pi by 2. This was the n derivative of x square sin x. Okay, now we will see one more example. Find the n derivative of y equal to x cube cos of 3x. Now here we will consider u as a cos 3x and v equal to x cube, and as we know already n derivative of cos 3x, because n derivative of cos of ax is a raised to n cos of ax plus n pi by 2. Therefore, n derivative of cos of 3x is 3 raised to n cos of 3x plus n pi by 2. And now again we are here stating the Leibniz theorem for y equal to u into v. That is, if y equal to u into v, then yn equal to n derivative of u into v plus n into n minus 1 derivative of u into first derivative of v plus n into n minus 1 by 2 factorial into n minus 2 derivative of u and second derivative of v plus n into n minus 1 into n minus 2 by 3 factorial into n minus third derivative of u and third derivative of v and so on, plus u into nth derivative of v. Now substituting the terms, therefore yn equal to un, first of all you have to substitute, that is 3 raised to n cos of 3x plus n pi by 2, and v is what? X cube here, plus n into u suffix n minus 1. In un you replace n by n minus 1, what you get? 3 raised to n minus 1 into cos of 3x plus n minus 1 pi by 2, and the first derivative of x cube is 3x square plus n into n minus 1 by 2 factorial, and replacing n by n minus 2 in un, what you get 3 raised to n minus 2 into cos of 3x plus n minus 2 pi by 2 into next second derivative, what you get second derivative of x cube is what 6x plus n into n minus 1 into n minus 2 by 3 factorial, and replacing n by n minus 1 in un, that is 3 raised to n minus 3 cos of 3x plus n minus 3 pi by 2, and third derivative of x cube is 6. Here only the derivative terminates. Now further you can simplify here, that is 3 raised to n cos of 3x plus n pi by 2 into x cube plus n into 3 raised to n minus 1 into cos of 3x plus n minus 1 pi by 2 into 3x square plus n into n minus 1 by 2 factorial into 3 raised to n minus 2 cos of 3x plus n minus 2 pi by 2 into 6x plus n into n minus 1 into n minus 2 by 3 factorial into 3 raised to n minus 3 cos of 3x plus n minus 3 pi by 2 into 6. Further simplifying, what you get? First term 3 raised to n as it is, cos of 3x plus n pi by 2 into x cube plus n into 3 raised to n minus 1 into cos of 3x plus n minus 1 pi by 2 into x square, because you have taken here already 3 here, that is 3 raised to n minus 1 and 3, we have taken here 3 raised to n plus, and now here 6 by 2 factorial, what will remain 3, and n into n minus 1 as it is, and 3 raised to n minus 2 and one more 3 means 3 raised to n minus 1 cos of 3x plus n minus 2 pi by 2 into x plus, now here 3 factorial means 6 and 6 will get cancelled, n into n minus 1 into n minus 2 into 3 raised to n minus 3 cos of 3x plus n minus 3 pi by 2. This was the n derivative of the given function.